Hey everyone, it's Alice here from Top Mark Science, and today we're going to be looking at microscopes, part 2. Throughout this video, we will be exploring the following AQA specification points: how to carry out calculations involving magnification, real size and image size, expressing answers in standard form if necessary, and converting between units, centimetres, millimetres, micrometers and nanometers. Let's get started. In our last video, Microscopes Part 1, you may recall that when we look at living things really closely, we see the tiny building blocks that make them, cells, discovered using a microscope by Robert Hooke, who observed cork and saw grids that reminded him of monastery cells, hence the term. And since then, science has progressed and developed microscopes of greater quality. Quality includes a greater magnification, measured in times, and resolving power, where many of today's microscopes can obtain details down to the nanometer. Tiny sizes on this scale may be unfamiliar to you, so before we dive in with some of these, let's start with some possible units you might already know. Pause the video here and convert the units below. Show the working where you can, and if you finish, try the challenge. Feel free to utilise measuring equipment that you might have to hand to help, such as a ruler or meter ruler. Let's go through the answers. While we do so, mark your work as we go. So 1 kilometre in km is the equivalent of 1,000 metres. 1 metre is 100 centimetres and 1 centimetre is 10 millimetres. You can check this one simply by counting the small lines in between the centimetres on a regular 30 centimetre ruler. Looking at the challenge questions then, number 1, what scale do you think microscopes can observe? Well, they can actually detect tiny sizes, and it depends on the unit conversions you do. But if you want to get a general idea, then the clue is in the name: microscopes, micrometers. Number 2, do you know any other smaller units and how we might determine them? We briefly saw a tiny unit of measurement in the beginning of this video, nanometers. More on how we determine those in a bit. And finally, write the units filled in above in standard form. Standard form is a way of displaying really large or small numbers in a simple manner. You obtain a standard form number by the number of decimal places the point needs to move to make it a number between 1 and 10. For example, 1 kilometre is 1 times 10 to the power of 3 metres, which is 1,000 metres, because the decimal point would have to move 3 places on the 1,000 to reach the 1. That means 1 metre is 100 centimetres, which is 10 to the power of 2, and 1 centimetre is 10 millimetres, which is 10 to the power of 1. Okay, now we have some basics out the way, let's dive in a little deeper to learn about smaller units, and just as importantly, how we convert between them, all because these conversions can crop up in exam questions. Metres are made up of centimetres. Centimetres are made up of millimetres. Millimetres are made up of micrometers, which are made up of nanometers. As an example of converting between units and how we do this then, let's start with a nice easy one. We already established that 1 metre is the same as 100 centimetres. This could also be read as 1 metre is made of 100 centimetres. To convert between units, we look at numbers we start from and end up on. Like here, we started on 1 and end up on 100. This is times 100. So to convert between metres to centimetres, we times by 100. So what about going back the other way then? Simple, reverse the process and divide by 100. Pause the video here to copy and complete this unit conversion chart. Use the method we just went through to help and replay the video if you need. If you finish, use your chart to help you complete the challenge. Let's see how you got on then. Do not worry at this point if you are unsure. Fill in the gaps as we go and annotate your work with the correct answers if needed, so you can use this handy tool in the future. So metres to centimetre conversions have already been done. Let's look at the centimetres to millimetres conversion process. We already established that 1 centimetre is made of 10 millimetres. To get from 1 to 10, we times by 10. So this times 10 goes in this section here. And remember to reverse the process when going in the reverse direction. So to go from millimetres to centimetres, we divide by 10. Moving down to the millimetres to micrometre conversion. It's already been started with a divide by 1000 to go from micrometres to millimetres. So reverse the process. Millimetres to micrometres is times 1000. And the same process for micrometres to nanometres. We've already been shown is times by 1000. The other way is therefore divide by 1000. Now looking at the two challenges then, this involves converting using two stages. Starting on the right is converting from metres to millimetres. So we not only times by 100, but by 10 as well. 100 times by 10 is times 1000. And simply reverse the process on the other side. So we now have a completed conversion chart. If you haven't already, pause the video again to use this to try the challenge. Otherwise, we'll go through the answers for this now. So 1 metre to centimetres is this jump here, which we can see is times 100. So 1 metre is 100 centimetres. 1 millimetre to micrometres is this jump here, which is times 1000. So 1 millimetre is 1000 micrometres. 5 centimetres to millimetres is this jump here, times 10. So 5 times by 10 is 50 millimetres. 2 micrometres to nanometres is this jump of times 1000. So 2 times by 1000 is 2000 nanometres. Now we're going to try and convert 6000 nanometres to micrometres. Nanometres is this jump here of divide by 1000. So 6000 divided by 1000 is 6 micrometres. And finally, 8000 micrometres to millimetres is this jump of divide by 1000. 8000 micrometres divided by 1000 is 8 millimetres. Now, not all conversions may be as simple as one jump. There might be times in exams and beyond where you may need to convert from, say, metres to micrometres, in which case you'll be multiplying by 100, 10 and 1000 in one go. Or you could simplify this and just multiply 1000 by 1000, which is 1 million. So 1 metre is made of 1 million micrometres. Now you can see this as a lot of zeros. We might make errors here and write the wrong number of zeros in our calculations. So this is where standard form comes in handy. 1 million micrometres can be written as 1 times 10 to the power of 6 micrometres. It would take the decimal point 6 moves to make it a number between 1 and 10. We can apply this method to the other side if we wanted to convert micrometres back into metres, but divide by 1 million instead. This shows us that 1 micrometre is 1 millionth of a metre. Again, look at all those zeros that can get complicated. So we can tidy this up and turn it into standard form to get that decimal place in front of the 1, and that would take 1, 2, 3, 4, 5, 6 jumps. But because this is a small number, it would become 1 times 10 to the minus 6 metres. This will just take some practice and familiarity to become confident with this. So far we've covered these two specification points. That leaves the microscope calculations left, which may involve unit conversions, hence covering these points first so we can apply this learning to the next part. Thinking back to part 1 of this microscope series, we came across the key structures of a light microscope. Two of these, the eyepiece and objective lens, make up an important part of determining the overall magnification of the microscope. The eyepiece has a lens and therefore its own magnification. So multiplying this by the objective lens magnification gives us the total magnification of the microscope. Pause the video here for a quick checkpoint to calculate the magnification in the following scenarios. Well done. Let's go through the answers. Number 1, 10 times 20 equals 200 times. 2 is 50 times, and 3 is 400 times. Nice work. So when we look at a sample under the microscope, what we see is a magnified image. It has enlarged the sample to make it look bigger without actually being this big. So how big are these samples actually? We can link these three words together: image, actual, and magnification in the I am triangle, where image is how big the specimen appears to look, and actual is the real size of the specimen, how big it actually is. If I want to calculate how big the specimen actually is, we need to know the image and magnification. As an example, let's say the image measures to be 10 millimeters at a magnification of 40 times. This leaves me to find A, actual. Notice how I've also listed the components as I am. An I am triangle means I want to find each part of I am. Listing them in this order means I am less likely to get confused later on. Covering up what I want to find out now reveals the equation I can use. When using triangles like this, we work from the top down, and the middle line is a division. So in this case, I would do image divided by magnification, so 10 divided by 40. This gives me a specimen actual size of 0.25 millimeters. Pause the video here quickly and have a go at this example. Use the same method that we just did. Okay, so in this case, we're trying to find actual size, which is image divided by magnification. 10 divided by 20. 0.5 millimeters is the actual size. Well done. More practice is to come, so don't worry if you're unsure just yet. Pause the video here and have a go at the following practice questions. Start with some easier questions on green and progress through the orange and up to challenge. Here, the questions require a bit more thought and application of what we have covered in this video. Right, let's go through the answers then. Mark and fill your work as we go. So question 1 was, if an image of a cell is 20 millimeters across at a magnification of times 40, calculate the actual size of the cell. Looking at the I am triangle and the question together, we've been asked to calculate the actual size of the cell. Therefore, I cover up A for actual. Now I can use the remaining letters to find the information, such as I, the image size, which is 20 millimeters, and magnification at 40 times. Using our rules to work from the top down and where the line is division, our calculation becomes 20 divided by 40, resulting in an actual size answer of 0.5 millimeters. For question 2, we follow the same method. If the actual size of a cell is 2 micrometers and the microscope is on times 400 magnification, calculate the size of the image. Now, we are calculating the image size, so I cover up the I and find the remaining information in the question, like the actual size, we've been told is 2 micrometers, and magnification, which is 400 times. Using the triangle with I covered up, I can see my calculation is going to be A times M, which I can then substitute in with some numbers to be 2 times 400, giving us a number of 800. But this time our units are in micrometers because that's what the actual size was given to us in, and no conversions have been asked for yet. Okay, question 3. If the actual size of a cell is 5 micrometers, the image size is 50,000 micrometers, calculate the magnification of the microscope. Now we're calculating the third component of this triangle, the magnification. So I cover up the M and see that I and A are left. We've been told in the question the actual is 5 micrometers and image is 50,000 micrometers. The triangle indicates that I do I divided by A, which is 50,000 divided by 5, giving us an answer of 10,000 times magnification. Moving into some slightly more challenging questions now, labelled as orange. This means there might be an extra step to consider in your calculations. Question 4 says the image size of a dividing cell is 100 millimeters and the magnification is 2,000 times. Calculate the actual size in micrometers. We can start this question in exactly the same way to identify what we need to calculate and use of the triangle. So we've been asked to calculate the actual size, cover up A, identify I, which is 100 millimeters, and M, which is 2,000 times. Using my triangle shows me I do I divided by M, which is 100 divided by 2,000. And this gives me an answer of 0.05. Now this is currently in millimetres, as the image was provided in millimetres. However, this would only get me part marks in an exam because the question has asked for the answer to be provided in the units of micrometers. So there is now a conversion required for that extra little bit. For this, we can refer back to our conversion chart and see that to go from millimeters to micrometers, we multiply by 1000. So actually, all I need to do is multiply my 0.05 millimeters by 1000, and this will give me an answer of 50 micrometers. Here is another question of a similar style. The actual size of a cell is 0.05 millimeters. The magnification is 2,000 times. Calculate the image size in micrometers. We're calculating the image size, so I'll cover up I. This leaves me with an actual size of 0.05 millimeters to note down and magnification of 2,000 times. Therefore, my calculation will be A times M, 0.05 times 2,000, which is 100. But again, this is in millimetres as provided by the actual size, also in millimetres. And seeing as the question has asked for the answer to be in micrometres, I need to convert. I can go back to my conversion chart to check what I need to do, and in this specific case, I times 1000. So I do 100 times by 1000 to give me 10,000 micrometers. Okay, last question of the practice questions, and this one might have an additional step compared to what we have just covered to add that extra level of challenge. The nucleus in a photograph of a cell measures 0.3 centimeters across. If the magnification in the photograph is times 500, what is the actual size of the nucleus in micrometers? So to answer this, I'm going to use exactly the same method as the green questions. We want to calculate the actual size, so I cover up A to leave me with I and M. Now the question hasn't explicitly given you what the image size is, but it has told you the photograph of a cell measures 0.3 centimeters across. This is our image, and our magnification is 500 times. Again, I follow the exact same method as what we've already done. Top of the triangle down, and division line results in I divided by M, which is 0.3 divided by 500 to give us 0.0006, or 6 times 10 to the power of minus 4 in standard form. But notice how the image size is given to us in centimetres, but the question has asked for the actual size in micrometers. Let's do some converting using our chart to get from centimetres to micrometers. For this, I will be doing 2 steps, times 10 and times 1000. This is the same as doing times 10,000. So returning to our calculations, we can do 0.0006 centimetres multiplied by 10,000, and this gives us an answer of 6 micrometers. Nice work, everyone. These things can feel tricky at first, but will start to feel easier with some practice and familiarity with the process. But this is all the new learning that we'll be doing for this video. So let's finish off with a summary quiz to see what we have learnt. Question 1. What is the unit for magnification? Times, shown by an X. Well done. Question 2. What do we multiply the eyepiece magnification by to get the overall microscope magnification? The objective lens magnification. Question 3. Something times magnification equals something. Actual times magnification equals image. Question 4. Which symbol represents micrometers? This one here, which looks like a funky U. And finally, what is wrong with this calculation? 5 millimeters times 10 equals 5,000 micrometers. This 10 is wrong. In order to convert from millimeters to micrometers, we multiply by 1,000. Nice work, everyone. Pause the video here to rate your progress on the following objectives to find areas of strengths and development. It will be useful for future revision. Thank you so much for watching this video, guys. If you liked it and would like to see more from Top Mark Science, you can like this video, subscribe to this channel, and you can now find us on Facebook for more teaching and study tips and general science updates. The link will be below in the description. That's all for now. Thanks for coming, and I'll see you next time.